My name is Nathan Peck, and I work as a senior developer advocate for container services at AWS. Today, I'm going to be talking about how you can use Amazon ECS with AWS Fargate as your gateway to serverless. Now, to set a little context for what I'm going to talk about today, I'm assuming that you already are familiar with what serverless is and maybe even sold on serverless. You want to build something serverless. But the next question that usually pops into folks' minds is how do I actually get into serverless without a complete rewrite? And the reason why this is important is because if you go to your CTO or your engineering manager or your product manager and you say, I would like to re-architect my system as serverless, but it's going to take me months. It's going to require a complete rewrite. We're going to have to stop feature development. They're probably going to look at you and say, no, we're never going to do that. But there's obviously benefits to getting into serverless, and there's benefits to building your application in a serverless style. But how can you build in such a way that you can smoothly transition into serverless without losing all the progress that you have already? So step 0 of this process is to identify dependencies of your application. If you look at a traditional application that lives on a server, it's not serverless yet, it usually has a characteristic of being built out of layers of changes that have happened over time. So here we have a server that's sitting there in the cloud, or maybe even in an on-premise data center, and it has different things installed on it. Let's say it has a version of Node.js runtime that was installed by one person 6 months ago. It has a system control setting that was made to tweak network performance that was made by another person a year ago. And then it has code and code packages that were uploaded, hopefully at the same time, maybe even at different times though. And so it's the sum of all of these things put together that make that server actually function. So identifying all these dependencies, what we want to be able to do is build a reproducible recipe for applying all of these changes onto an empty shell of a server in order to set up the application environment for an application. So this is the first step from going from server full to serverless, is we want to be able to have that server as an empty shell and bring the runtime, bring the code, bring packages, and bring settings to that machine as one application artifact, and containers are a great way to do that. So containers, it basically provides a reproducible recipe for building your application environment. You can turn that recipe into a container image, which can then be delivered to any machine that you want. So once you have that recipe, once you have that application separated from your infrastructure, you'll find that you're able to take that container image, you're able to run it locally, you're able to run it on an on-premises server, and you're able to run it in the cloud on different types of compute in the same way. It'll run the same way no matter what. So the second step, step 2, is how to create a description of how to run the app. So you have your application artifact, which defines the application, but there's other things that are necessary for the application to run. So the application is probably going to need some CPU. It's probably going to need some memory. You may need to run a certain number of copies of the application. So the description of how to run the application is basically going to be a manifest file that lists out all the settings required by the application to function. And you're going to hand that off to a tool, an orchestrator, in this case, Amazon Elastic Container Service, and ECS is going to understand how to turn your description into a reality of a real-life deployment on some type of compute capacity. And the cool thing about Amazon ECS is it's a continuously reacting system. So if I tell it I'd like to run 4 copies of my service, it's going to launch 4 copies of my service. And if one of them crashes and the deployment goes back down to 3 copies, Amazon ECS is constantly watching over the system. It's going to readjust back up to 4 copies. So think of it as a description which is continuously monitored and then continuously reapplied going forward to self-heal back to whatever your description said you wanted your application deployment to be like. So Amazon ECS has the application artifact. It has a description of what you would like to run and how you would like to run it. The next step is you need capacity to run the application on top of. So that's step 3, provide infrastructure capacity to run on. And the amazing thing about Amazon ECS is that it can run across multiple types of compute, and in fact, multiple types of compute simultaneously. So here you see on the right-hand side, you see an on-premise server, Amazon Elastic Compute Cloud, or EC2, and AWS Fargate. So let's start with ECS Anywhere. On the right here, you see a picture of some Raspberry Pis and a little Raspberry Pi cluster that actually lives over here on my desk. And this Raspberry Pi cluster is a 16-core, 32 gigabyte ECS cluster that's providing capacity for running containers. Amazon ECS lives in the cloud inside an AWS region, but it's able to connect to this cluster and orchestrate launching containers on this on-premise hardware that is just hooked up on my home internet connection and on my desk over here at home. But what if you don't actually want to manage hardware? Obviously, with my device over here, I have to manage the electricity to it. I have to provide cooling. It's a cooling fan running. You may even be able to hear it over my mic right now. So that's not ideal. I don't really want to manage hardware all the time. A lot of times I would like that to live in the cloud. So Amazon ECS also works with EC2, which is VMs on demand in the cloud. ECS allows you to treat an EC2 VM as capacity, and Amazon ECS will pack containers onto that VM capacity as needed to fill it up. So here we see on the right-hand side one VM that's actually running 5 different applications. Now, a step beyond that, and here's where we start to get into serverless, is AWS Fargate. So Amazon ECS, instead of using a VM as capacity, can actually talk to AWS Fargate and say, AWS Fargate, I would like you to run this container on my behalf. And what AWS Fargate does is it actually launches each container in its own isolated micro VM that's needed to run that container of that particular size. And so instead of having one large VM that's shared between multiple applications, every single instance of your application gets its own small isolated micro VM. So this is very cool, very convenient. So putting all the pieces together, that migration process, what it looks like is first I need to optimize my application to be a serverless application. That involves creating a pattern and creating a manifest file for a Docker file that says, here's how I would like to package up my application and put it together into a container image. Once that happens, I can now ship that container image anywhere. Next step is I provide serverless orchestration. So Amazon ECS is a serverless orchestrator. I don't have any version to manage there. I just have an endpoint which lives on the internet, and I can talk to and provide my task definition to say, here's the container image I would like to run, here's the settings I would like to run it with, and here's however many copies I would like to run it with. And then the last step is the capacity. I could start out on non-serverless capacity, but over time, I can actually transition my application into serverless capacity on AWS Fargate. And AWS Fargate can be launching micro VMs on demand to host my application. So once I have all 3 of these set up, I've actually made a smooth transition into serverless without having to rewrite my application. I just had to package it up into a container. I had to build my manifest, and then I had to provide serverless capacity for Amazon ECS to run the application on top of. And I'm actually going to demonstrate this. It's demo time. So first thing I want to show is how I would actually define this type of setup. And you'll see here a sample task definition. This is defined inside of CloudFormation. CloudFormation is an infrastructure as code language that allows you to define resources you would like to create on AWS. And this task definition is the manifest that describes what application to run and how to run it. And so you'll see here I have an image. This is an address of an image that I've built. It's just a standard Node.js image, but it could be any application that I can package up inside of a container. I can plug that into the task definition. I specify how much CPU and memory is required. So in this case, 256 CPU is actually 1/4 of a CPU, and memory is 512 megabytes. And you'll see here in this task definition, I've said requires capability EC2 and Fargate. So the interesting thing about this task definition is it's actually going to be capable of running both on traditional VM capacity and on serverless Fargate capacity as well. And I specify a couple other settings, such as what port the application list is on, how to gather up logs for the application. Now, The next step is to tell ECS to run that task definition manifest as a service. And so that's what you see here. I'm actually provisioning 2 services to demonstrate the cross capabilities of Amazon ECS. So there's an EC2 service, which is probably how you would start out if you're not currently on serverless capacity. Maybe you're more comfortable running on top of an EC2 instance. You can use Amazon ECS with an EC2 capacity provider here to spin up that task definition, a sample task definition on top of EC2 capacity. And I'm saying to Amazon ECS that I'd like to run a certain number of services, copies of this application. But I can also use that exact same sample task definition here to say I would like to run on Fargate. And so with Fargate, the cool thing is all I have to say is launch type Fargate. I'm relying on Amazon ECS to supply the capacity to run the application. And I don't have to specify anymore that there are EC2 instances. All I have to specify is a network configuration for what area of Amazon VPC I'd like to network those copies of the application within. Now, you might ask, okay, this looks like 2 different services here. It's an EC2 service and a Fargate service. How am I going to be able to seamlessly transition from one to the other? I don't want to rewrite everything. I don't want downtime as I go from server full to serverless. And to answer that, I'm going to demonstrate how to do that inside the application load balancer using custom forwarding rules. So here you'll see there's a target group for EC2, and there's a target group for Fargate, and there's one load balancer here. This one load balancer is going to be how traffic from the public internet gets to my application. And within that load balancer, there's a listener that has a forwarding configuration that actually splits traffic 50-50 between the EC2 instances of the application and the Fargate instances of the application. So this is super cool because it allows me to actually create a service that's powered by both EC2 and Fargate and seamlessly transition between the two in either direction. If I want to go from EC2 to Fargate or Fargate to EC2, I can do that. And I'll show you what this all looks like when I deploy it inside of the Amazon ECS interface. So here I have loaded up my cluster. It has a long auto-generated name. It's not the prettiest, but you get the point. It's using capacity providers in this environment. And I'm running 2 services. There's a service that is on Fargate and a service that's on EC2. And if I click into tasks, you'll see the tasks that were launched. I'm running 2 copies of each service. And you'll see that under launch type, some of them are EC2 and some of them are Fargate. So I'm actually splitting the capacity 50-50 between running instances of my application in a VM manner and running instances of my application in a serverless manner. Now, if I click into services and I click on one of them, let's, for example, the Fargate version of the service, I'll see a load balancer here. And I've actually already loaded up that load balancer to show you what that looks like inside of the Amazon EC2 dashboard. I can see that there's listener rules set up on it, and it's forwarding traffic in a 50-50 split between Fargate and EC2. And obviously this is because I'm running 50% of my containers on a traditional VM and 50% of my containers on Fargate. If I was to, for example, start scaling up and say, you know what, I don't love VMs anymore. I'd like to become more serverless. I'd like to run more on Fargate. I could adjust these balances as necessary and start sending, for example, 75% of the traffic to serverless Fargate and 25% of the traffic over to a traditional EC2 VM. Or maybe I like to go the other way. I have a very specific EC2 generation that I like, the latest and greatest processor. I love the speed on it. And I would like to have higher performance by packing containers onto an EC2 instance. I could go the other way. I could start running 75% or even 100% of my traffic on EC2 and slowly dial down the Fargate. I have full control over that. And you can see inside of the load balancer, it's just keeping track of the IP addresses of the tasks that were launched by ECS and whether or not they were healthy. So here's what that ends up looking like when I put it all together. I have an endpoint here, which is being powered by both EC2 and Fargate. As I refresh this, you'll see the capacity type switches back and forth between EC2 and Fargate, as I hit different instances of the application. There's 4 different ones that I'll see DNS IP addresses pop up for here on this list. So that's pretty cool. And going back over here once again, I can look at the cluster and demonstrate that I am running multiple copies here. I can also scale them up. Like, let's say I want to start running more in Fargate. I can update my service here, and I can say I would like to start running 20 instead of 2. And the advantage of this is I no longer have to manage the VMs. It's going to spin up Fargate containers on demand for me to supply my needs. So hopefully this demo has shown you that you can use Amazon ECS as a way to gradually transition from Fargate to EC2 or even EC2 to Fargate. If you're currently running an application that is not serverless yet, you're running directly on an EC2 instance or directly on a VM, the steps to go through are package up your application to a container image, push that container image to the cloud, define a manifest for the application, which can run on either EC2 or Fargate. Now you can start to spin up copies of the application across both EC2 and Fargate simultaneously with Amazon ECS. It supports both. And you can experiment and choose without really forming a complete commitment to either one. If you choose that you like EC2 better, you can scale in that direction. If you choose that you like AWS Fargate serverless capacity better, you can scale in that direction. So I hope this demo helps out and helps you understand the process of going to serverless and using Amazon ECS as that gateway to serverless for your application. Thank you very much for your time.